Welcome to Rawson Connection, a podcast about all things Lehigh engineering. Coming to you from the PC Rawson College of Engineering and Applied Science at Lehigh University. It's a show for students, alumni, faculty, and staff, current, former, and future, and for anyone interested in the many creative ways that engineers are solving the world's problems. I'm your host and producer, Christine Fennessy. So this year, 2021, marks the 50th anniversary of female undergraduate education here at Lehigh. And the university is doing a lot of things to mark the occasion. There's going to be events, lectures, exhibits, podcasts, and the goal is to really celebrate the impact of all women on campus, past, present, and future. And you've probably seen the logo, but if not, this year-long celebration is called Soaring Together. And Rawson Connection is marking this milestone too. We'll be bringing you even more stories from our female faculty, and they're all making an impact in their departments, on their students, in their fields, and on the world. We're kicking off this series with Hannah Dailey. Hannah has a pretty unique Lehigh story. She started here as a mechanical engineering undergrad. She left for a while and did some pretty cool stuff. Then she came back and got her PhD here. And now she's an assistant professor of mechanical engineering. In today's episode, she talks about that journey, how she went from a terrified transfer student to launching a startup to specializing in medical devices. She also talks about never having a single, not one, female professor for any course, ever, and about the challenges, efforts, and the wins in getting more female students and faculty into the mechanical engineering department. And one quick listening note for those of you who might not be familiar with our college shorthand, you will hear Hannah say Mechie or Emmy. That's just our verbal shortcut for mechanical engineering. Thanks for joining us.
My name is Hannah Dailey, and I'm an assistant professor in mechanical engineering and mechanics, and I feel like I've been at Lehigh for my whole life, I guess.
And why do you say that?
So I grew up as a little kid hearing about what a special place Lehigh is from my grandparents. My grandfather is a Lehigh alum. He graduated in the 40s, and when I was a kid, my grandparents would sometimes swing by Lehigh on one of their summer vacations, visiting friends, and they'd pick up an admissions packet and bring it home to me to look at. But I didn't really seriously think about going to Lehigh until I was in high school, and I decided that I wanted to be an engineer. And then, of course, Lehigh has a great reputation as an engineering school. So then I started to look into it more seriously, and I was like, oh, this looks like it could be the perfect fit.
Okay, so let's step back for just a second because I am curious, who was the kid he was bringing that admissions packet to?
Oh, I was the last hope. I think they did this for all their grandchildren. But then it came to my turn and I actually took the bait. I don't know if when I was a little kid, people would have said, oh, that one's going to be an engineer. Although I did always really enjoy understanding how things worked. Like one of my favorite books when I was a kid was David McCulley's The Way Things Work. And I would pore over those pictures and try to understand them. And I enjoyed doing hands-on projects with both my parents, actually. They're both very hands-on people. Did some carpentry and building projects, a little bit of mechanic stuff with my dad. My mom, I did a lot of handcrafting and sewing. And, those can be quite architectural construction projects when you really think about it. And so there was a lot of hands-on stuff that we did together. I also loved Legos. Lots of Mechies grow up saying, oh, I loved putting together Legos, but my favorite was Lego Technic, the ones with all the gears and everything. So I think that there were definitely some signs, but I didn't have a lot of engineers in my family or people that I could turn to and ask questions like, what did the different kinds of engineers do? So I did what a lot of students do. I made a relatively uninformed decision and picked mechanical engineering because it sounded like things I like and also very broad. So I knew I was going to have a job of some kind when I was done with that degree.
Tell me about one of those projects that you did as a kid that really stands out in your mind, that the light bulb was kind of going off a little bit in your head of could I do this for my life?
Oh gosh, I don't know if I had a light bulb moment. My family, I think we did a lot of over-ambitious epic projects. We built a train table with a mountain to go under the Christmas tree. And I remember like my dad and I ruined the concrete porch in the back patio because we were like pouring the mountains in minutes. It's like a 2-part expanding foam. So you mix the 2 parts of it together and then it starts exploding everywhere. He ruined like a spatula and we got this on the floor. My mom was mad, but also, I mean, we had that train table under the Christmas tree for my whole life growing up. And I think that's a characteristic that sometimes a lot of engineers share. This idea that you have to be willing to do things that you're unprepared for, that you haven't already learned how to do. I think that that can sometimes be a struggle for our engineering students to get their heads around the idea that you're going to be asked to do things in life that nobody gave you the formula for in advance. But you got to just get in there and try, and then you'll surprise yourself with what you can do.
You did talk a little bit about what kind of drew you to mechanical engineering, but were you even aware that there were so many different disciplines in engineering? And even so, even if you were, why mechanical engineering out of all that were available?
That's a great question. Okay, so, I'm going to take you back to like my 17-year-old self. And one of the things that was certainly true for me, and I see it a lot in students now, is that you have a lot of stereotypes about what you think different disciplines are. So I started going down the list of the available types of engineering. So by the process of elimination, I excluded chemical engineering because I really did not enjoy chemistry. To my great regret, I excluded computer science and computer engineering because I thought that was just for hacker boys who like to stay up all night and dropped out of high school, which is totally an unfair stereotype, but that's what I thought that it was. And so, I kind of like came down the list and then I got to mechanical engineering, it's like, well, I really enjoyed all of my Lego sets that had gears and I enjoyed learning about the simple machines and the way things work. And I kind of like thinking about how things work and take them apart and put them together. And sure, that sounds great. And so then when I got into Lehigh and I started taking my classes, each semester just validated that choice because I really enjoyed what I was learning. There were very, very few classes that I ever had as a mechanical engineer. In fact, I can't even tell you one where I was like, I absolutely hate this. And if I had to do this for my job, I would die. I just enjoyed it. And so that helps to build your confidence that you're doing something that's going to be a good fit. Because even when it's hard, if you find it interesting, that's a little bit inspiring to put the work into it.
Oh, totally. Okay. I do want to know a little bit more about your experience as an undergrad in mechanical engineering. Like, what was it like for you coming into that program? Like, did you know what you were getting yourself into? Were you full of self-confidence and self-assured about what you were doing? Or was it not like that at all?
Oh, no, it was not like that at all. I was terrified. And part of it was because I technically came to Lehigh as a transfer student. So when I was in high school, I grew up in Florida, and Florida has this really cool program for accelerated high school students where you can take classes and get dual credit toward your high school degree and also community college credits. So when I came to Lehigh, I never had a freshman experience and I moved straight into like sophomore housing, and everybody knew what they were doing and they knew where they were going and they knew why they had chosen their major and they already like had the lay of the land. And I was desperate to not appear to be like a total fool. So I just kind of like, I remember the day before the first day of classes, I walked campus to try to figure out my route and know, this is before smartphones. Like I had it all printed out. I was like, okay, I need this many minutes to walk from here to here because I just wanted to do it right, Which in retrospect, I wish I could have gone back and told myself, look, the people around you are just as scared as you are. Like it's all new and different. I would have told myself to chill out for sure. But I wanted to make a good impression and prove to myself that I wasn't crazy for wanting to do this and I could pull it off.
When you started, do you remember or have some idea of the ratio of male to female students in mechanical engineering?
Yeah. So our long-term historical average, I'm really interesting that you bring this up because this is an area that we're really working on. We're very, very committed in mechanical engineering to improving our diversity representation in the department across all levels, for undergraduate students, graduate students, and faculty. This is really important to us. So we've been looking at some long-term historical data. And for women, we're doing a little bit better, like not just at Lehigh, but mechanical engineering as a discipline. We're doing a little bit better than we were 20 years ago, but we're not one of the ones where girls tend to flock. So my experience was probably very similar to what students have now when they're coming into our department. Something like 15 to 20% of the class would be female students in any given year. At Lehigh, we're doing actually awesome as a college of engineering in representation of women who are getting undergraduate degrees in engineering. And that's something I'm very proud of that, we can say at Lehigh, we're doing above national averages. But, getting those girls who have chosen to be at Lehigh, who want to be engineers, to be excited about mechanical engineering, that's something that I really want to work on. Because there are, again, some discipline stereotypes where people look at mechanical engineering and they think it's something, but it's more than cars and planes, which are awesome and very cool. But if that's not something that you're into, I would love for more women to know that there's still a home in Mechie for them too. Like I do medical devices, which a lot of people don't expect to find in mechanical engineering. They expect to find that in bioengineering. And then once you get into it, you realize that Mechies are the ones who design and build things. And if you want to have a positive impact on society, medical devices is an awesome career path to go into because you can help to alleviate human suffering through the things that you design. And that's a really cool thing that makes me feel very inspired. And I want to help broaden perceptions around what mechanical engineering is so that more students from more diverse backgrounds can be seeing it as a pathway where they can fit.
What are the other surprising aspects of mechanical engineering that you would want prospective students to know about?
Well, what I always tell students is think about everything that you've touched and interacted with today, just today. Your smartphone, the pen that you pick up, the doors that you open, the car that you drove in. Like every single thing that you have touched and interacted with had mechanical engineers who were involved in designing it, building it, testing it, breaking it, redesigning it, and making it better. And so kind of regardless of what you're interested in, there is a job for a mechanical engineer who's going to be part of that. And I think that that can be both very exciting and also a little bit overwhelming for students because you don't maybe have the luxury of having a real clear picture in your mind of what you might be doing at the end of your 4-year degree. But it's also exciting because of the breadth of things that you can get into. We have students who are definitely in the aerospace and the automotive industries and loving that. We also have students who are doing all kinds of cool jobs in places where you would never even think that a mechanical engineer would end up, bottling and packaging to medical devices. Like there's just so many things that you can do with that degree, but you got to get them in the door in the first place. And that's something that we're really working on very hard as a department.
Oh, that's great. That's so good to hear. Okay, so tell us the story of how you went from an undergrad to now being a professor at Lehigh. Because I'm not sure in the engineering school, at least, how many of you there are with this story.
No, and there are not very many, and it's not a very typical pathway. So after I got my bachelor's in mechanical engineering, I went to work for the Naval Surface Warfare Center in West Bethesda, Maryland, and I loved that job. It was really fun. It was one of my first immersive experiences in a research culture. I was actually kind of in a small group at NAVSE of people who all had advanced degrees. Most of them were PhDs. There were one or two guys who had a master's degree. And it sort of dawned on me because my supervisor said it like, hey, you seem like you'd be cut out for research. You should consider going to graduate school. I was like, oh, I should consider going to graduate school. So I applied to a bunch of different schools and I ended up coming back to Lehigh because they gave me a nice offer to come back to the graduate program. And also just because I loved Lehigh so much, which is not a reason why people are supposed to make decisions, but I just did. I mean, like I said, I grew up since I was a little kid. Like we love Lehigh. So when I had a chance to come back for grad school, I was like, yes, that sounds great. So I did that. And then when I graduated with my PhD, I ended up with an unexpected opportunity to move overseas. So my husband was also finishing PhD. His doctorate from Lehigh is in electrical engineering, and we were expecting a baby and got a chance to move to Ireland. And he was hired into a national institute called the Tyndall National Institute in Cork, Ireland. And I got an offer to work at a medical device incubator in the Cork Institute of Technology. So I ended up kind of falling backward in an unplanned way into the orthopedic industry through this medical device incubator. And I had no prior background in orthopedics, but I figured I had enough skill set as a mechanical engineer that I could figure out what I needed to know. And so that was a real turning point in my career because I fell in love with orthopedics as a discipline. And that's what I do now. And it has really defined like the last 12 years of my life have been completely and totally devoted to this idea of orthopedic biomechanics, and specifically what I study is bone fracture healing. So this is a super cool process of restoration of mechanical integrity of a tissue structure. And what makes bone so special is that it heals itself with itself instead of with a scar. And that's just once I learned about that process, it was so intensely fascinating. And then knowing that there are mechanical conditions that we can change through the design of implants that are going to change the biological response during that process of the bone healing itself, that just like ignited a passion inside of me that I hadn't felt for the jobs that I had before that I enjoyed. But now I felt like this is the thing that I want to do, that I could devote my life to. And so that is what I do now.
Wow. So how did that translate into you coming back to Lehigh and becoming a professor?
So that was because of my accidental adventure as an entrepreneur. So I am very much an engineer's engineer. I am risk averse. I plan things. I have spreadsheets for packing lists when we go on vacation. Like I do not fly by the seat of my pants for anything that I do. But then when I was working in Cork in the Medic Center, that was the name of the incubator, I had worked on a technology for an orthopedic implant and had a couple of really lucky breaks, including some funding that I won from the Irish government to advance the research. And we had gotten to a point where we had evidence that this technology actually might be viable for improving the bone healing response. And so that's sort of, once you get to kind of animal level research, that's sort of the end of the road for what people typically do in academia. And then if you want to advance it further to the commercialization stage for a technology, then you're really talking about a startup. So I had this opportunity that I didn't want to miss out on to get involved in founding a startup company with 3 other guys that I had worked with, 1 orthopedic surgeon and 2 other engineers from this incubator who had long careers in medical device process and product development in industry. And so the 4 of us get together and like, okay, we're going to do this. And that was in 2014. We made the decision to do this. So during the lead up to founding the company, I had considered going to work for a multinational orthopedic company. And while I was trying to decide what I wanted to do, because, I would have had to walk away from this thing that I had been working on to go and work for one of the household names, I was adjunct teaching at Lehigh and I was taking care of my 2 very little kids. I had a 3-year-old and a baby. And as life was crazy. My department chair at the time responded to a Christmas card that I sent the department and said, hey, would you be interested in doing some teaching? And I was like, sure, I'll do some teaching. So then I got back in the classroom at Lehigh and decided that I was really enjoying that component of it. And then they eventually interviewed me for a tenure track position. So then starting in 2015, I became a member of the tenure track faculty. And then I started working on the research that takes place in my group today at Lehigh.
Now, tell me a little bit about your research. You've talked a bit about it, but break it down to its basic components for the lay listener here.
Yeah.
Because it's very cool. We've talked about it a lot, but I want to make sure that people really do understand what it is that you're doing and how cool it is.
Aw, thank you. Well, okay, so break it down to its most basic pieces. Sometimes bones break. And after they break, most of the time, if you're an adult, you get some sort of surgery to help put the bones back together while the body's natural healing process can take place. The orthopedic implants are, generally speaking, very mature technologies. So most of the time things go well, but sometimes they don't. And when that happens, a patient can experience lingering pain, disability, sometimes necessity for additional surgeries over a period of many months or years. It can be a real problem if a bone fails to heal. And there's a lot of reasons why that could take place. It's usually a very complicated cocktail of factors. There's risk factors based on a patient's kind of baseline health status. So if a bone is healing slowly, typically the only way a surgeon can tell is by looking at x-rays. And x-rays are very difficult to interpret beyond just kind of qualitative visual inspection. Like, what am I looking at? Does it look like it's healing? And when it's healing well, it's really easy to see that it's healing. But if it's healing really slowly, or if it's not healing, it's really hard to see if there are any changes over a period of weeks and months. So what ends up happening is this long waiting period for a patient who may end up someday needing a second surgery, but we're waiting, hoping that that healing response is going to take over. So as a mechanical engineer, I look at that problem and I think to myself, that is just a problem of a failed structure, right? And we should be able to find out whether that structure is making any progress. And the way that we can find out is by taking three-dimensional medical images. We do CT scans. So some people call them CAT scans. CT and CAT, it's the same thing. CT stands for computed tomography. So it's like a three-dimensional X-ray picture that we can put back together. And then we can build a three-dimensional model in a simulator, the same way that we would run a simulation of any other mechanical structure, part of a car, part of a plane, a bridge that people might walk over, like any kind of mechanical thing. You can do simulations on that. So that's what we do on the bone, but it's just put back together from the image. So we extract all this information out of the image, we make these 3D models, and then we do what's called virtual mechanical testing. So we can take this 3D model that we put together and we could pretend like we're putting loads on it. And those loads can be anything. It can be like a patient weight bearing, and they can be very specific types of mechanical tests. And then by looking at the response of the structure, you can tell, is it healed or is it not healed? And there's usually a score that we can assign to it. So is it 10% healed? That's very concerning. Is it 100% healed? Patient's good to go. So this whole idea of using imaging is really exciting because it's not invasive. You can get a low dose three-dimensional image. It doesn't require much more radiation exposure than just getting an X-ray. And then you can get all of this very helpful information. So what I'm trying to develop with my research here at Lehigh, among the other projects, this is a big one. I'd like to have a diagnostic test that a surgeon could order. So in addition to getting the CT scan, we want a little virtual mechanical test that could be ordered to provide a quantitative and actionable decision point so that we know this patient is 5 months along after their surgery. They're at 10% healing. This is justification to proceed with an intervention. And that's really important because in the grand scheme of the overall necessity to reduce the cost of healthcare, because healthcare is so expensive, we don't want to be doing unnecessary interventions because there's, costs and risk associated with that. We want to be able to know which interventions are going to be clinically beneficial, and we want to be able to do what's called evidence-based medicine. And so having these kinds of tests that are very quantitative, and that just means you have a number score instead of somebody's impression, right? I feel like what I'm seeing is good or bad, as opposed to it's 10% or it's 50% or it's 100%. So we want a quantitative outcome measure that we can say, yes, we should intervene, or no, we should not. And that's what I'm trying to develop. And in addition to that, I have other research that's all very closely related to bone fractures and how they heal. We're really interested in kind of the basic science of how mechanical conditions influence the bone healing response, either for good or for bad. So we do computer simulations of that. We do computer simulations of putting hardware and bones together and looking at how they interact mechanically. But it's all related to these basic ideas of surgeons understand the mechanics because they're orthopedic surgeons are very mechanically inclined, but they can't actually measure what they're interested in because they don't have the tools. So in my lab, we're trying to provide the tools to do the measurements that can help inform their patterns of practice, design better clinical studies, get better diagnostic tests for being able to make those difficult decisions when they come up. And that's the vision.
And what makes this research just so meaningful to you?
Oh, gosh. So for me, I love the idea that every day there are patients who are coming into hospitals, into trauma centers, who are kind of at their worst day of their life yet so far, right? You've had a traumatic accident. You've been in a car accident. You crashed your motorcycle. You fell off of a ladder. You're all banged up. You're at kind of a low point. And the surgeons there are going to do their absolute best to put those patients back together and get them healed and restore their function, their mobility, their ability to work and play with their kids and do the things that they love in life. And as an engineer, I will never operate on a person. But if I can contribute to either the basic science understanding of how bones heal or to the technologies that are used for doing those surgeries, and if I can have an impact that improves the way that patients have healed, I absolutely love the idea that I have contributed to restoring life and mobility and freedom of movement to people who have lost it as the result of an accident. And that's a very inspiring thing for me to feel like I am part of that.
Yeah. And you have a team that you're working with. You have students that you're working with. Mm-hmm. And how do you see your enthusiasm and drive and commitment to this, like, rubbing off on them? Like, when they first come in, do they not maybe have a sense of just how important this could be? Have you seen that sort of evolve over time with some of them? Like, what is it like to see that mission kind of becoming more and more clear to your students as they work with you on this?
That is an amazing question. I love it. So the evolutionary process, when students first come into the lab, they begin totally overwhelmed and very terrified, I think, because we use so many different software tools and we have this like enormous rack of computers in the corner of the office, and it's very technical and it's very overwhelming. And nobody starts by just washing glassware in a sink, because we don't do that, right? So they have a lot to learn. And over the period of months or years that they're working on a project, they start to read more in the literature and understand why these unsolved problems are still really important in clinical orthopedics. And then they begin to see how what we as engineers, specifically mechanical engineers, can contribute to solving these unsolved problems. And then it's cool to see that individual sense of ownership. So I just had a student who graduated, and like at the end of his PhD, it was very cool to see that he could stand up and present and answer questions in exactly the way that I would, like laying it out so that people who are not us, they don't understand what we do, totally understand why this is so important and why it's so exciting. And so I think, it's sort of a two-way street. I hope that the students are able to understand, why I'm so excited about these problems, why I think it's so cool what we do, but also that they can sense my commitment to them as scholars. I try to be generous with my time and, make it clear to them that I'm like on their team, like as much as they're on my team, we're doing this together. I have a new PhD student in the group, and he's just putting together his very first author paper, which is a huge milestone, like that first paper that you write. And I said to him, like, research is like a road that you're building as you travel on it. Like if we knew in the beginning how to get around all these like little sticky corners of putting together this study, it wouldn't be research. But this is a thing where it unfolds naturally as we do it together. And then you can reflect backward and see how far you've come, because you look over your shoulder and you see, oh, wow, all the things that I didn't know even 6 months ago. And that's a cool feeling to have. But you have to be open to the little setbacks that come along the way, because that's just part of building your own pathway.
Oh, absolutely. All right. Let's just pivot to another topic here, back actually to what you said earlier. You mentioned earlier that the mechanical engineering department is actively doing things to encourage more female students. And so can you talk to me about what some of those efforts are?
Yeah. Okay. So in mechanical engineering, we have a diversity, equity, and inclusion working group. So it's a small group of faculty who are specifically focused on, kind of taking a look at our department and understanding where we're at right now and setting some goals for where we want to be. And particularly in the representation of women and underrepresented minority students and LGBTQ plus students, we really want to be a leader here at Lehigh and a leader nationally. That's clearly our ambition, is to get there. And so with women, I think there's a really exciting opportunity at Lehigh, because our engineering school as a whole has great representation of women. We're not at 50-50, but we're definitely doing better than national averages. So the women are here. They've come to Lehigh. They want to be Lehigh engineers. And so now it's our job to get them excited about mechanical engineering. And we've done some strategic things to try to pull in people who have less siloed research interests and more multidisciplinary interests. So we restructured, for example, our master's programs, which is very common for students, especially now, to recognize that a bachelor's degree might not be quite enough to get them the types of jobs that they want, especially in emerging areas. And so there's a lot of students who are interested in doing bachelor's plus master's. So we did a lot of things with our graduate program to make it easier to do those degrees quickly, to get them done in a year, and to make it easier to do multidisciplinary degrees. So let's say, for example, that you are a student who's really passionate about energy and environment. Well, mechanical engineering is a great degree to do. We give you lots of opportunities in the undergraduate curriculum to pick and choose from electives in other engineering majors and other science majors to bring in your interests into your degree. And a lot of people don't realize that you can do that. You don't have to take all ME classes the whole time. You can bring these other things in. And then if you build that together with a master's degree program, we have an interdisciplinary option where you're actually only taking about half your classes in MECE at the graduate level, but then you can put together the degree that fits you and the career that you want, whether that is energy, whether that's in robotics, whether that's in machine learning, computer science, whether that's in medical devices, bioengineering. Like, you can put together something that's going to get you where you want to go. So we're really excited about that, because this is not just the traditional mechanical engineering. This is a much more broad-based approach. And, if I were a student coming to Lehigh now, I'd be very excited about that.
All right, switching to faculty, what are the efforts of the department right now in trying to attract and retain more female faculty?
Well, it's very exciting that there are female faculty now. People are astonished when I tell them this, but I never had a female professor for any course that I took.
Really?
At any college ever.
Wow, that's amazing.
Yeah, no, I know it worked out that way. There were no women on the faculty of mechanical engineering when I was a student. But now we have a few. And actually, I'm very excited that we have just hired another tenure track faculty member, an amazing woman. Her name is Ebru Demir. She's coming to Lehigh. Her area of research is mechatronics, and so kind of like mechanical and electronic devices. And this is something that our students are so excited about. And this is an area where we really want to have more accessibility for them to be doing projects and lab experiences and research. And so it's very cool that she's coming. Lehigh, and specifically mechanical engineering, is very aware that our faculty needs to reflect our student body, and that both of those things really do need to reflect larger society. We have a long way to go, and this is not a ship that you can steer on a dime. And part of that is because when you have gross underrepresentation of certain groups starting at the lowest levels of education, like what are the kinds of students who go to enrichment programs that are targeting STEM? When you recognize that there's a limited pipeline of diverse representation, then you have to work even harder to try to keep those students from the undergraduate level into the graduate level, and then into postdoctoral training, and then into faculty positions. But it's something that I know Steve DeWirth, our dean, is very, very committed to, and the highest levels of leadership at Lehigh are very committed to. And so we're excited that there's potential for transformation, because it does really require that long-term commitment to get from where we are now to where we'd like to be. I'd like to see 50% women sitting in my classes. And I don't think that's crazy, because, women and girls have all the same aptitudes that boys and men do. And it's just cultural forces that tell us things that we're good and not good at that really become quite insidious, starting in the kind of like preteen, tween years. I have a 12-year-old and a 9-year-old daughter. And so this is something that's on my mind all the time, because I see the messaging that's coming to them about the things that they should be interested in and the things that they should not be interested in. And it's really a tough battle to fight, but it's worth doing, because there's a lot of research that shows that more diverse teams are more creative and more productive. And so the more that we can do as a society to build that pipeline of kids that want to be engineers, who come from all different walks of life and all different kinds of experiences, the better we're going to have in terms of outputs from those people, right? Their creative products, their inventions, their technologies that they bring to market, the kinds of problems that they want to solve. Like, if you're too narrow in your representation, you're only going to be solving the problems of people who are like you. And then that's a much more limited scope for impact for what engineers can think of and dream of and do. So these are big problems, but it's something that we're very committed to working on. So I'm excited.
That's great. I'm excited for you too. In considering your own arc at Lehigh, what do you draw on from your own experience as a student and now as a professor to help support students to keep them there?
I think the most important thing that anybody wants to hear, certainly that I've always wanted to hear, is how much you are valued just by being there, and that you're doing great. I have had a lot of experiences of female undergraduate students coming to me, either because they're my advisees or just because they know that they can come to me, worrying that their academic performance isn't good enough. And then when I look at their academic performance with their permission, I realize they're doing just fine. It's just that voice in the back of your head that's telling you, I don't belong, or I'm worried that I don't. And so having somebody to just say, you're doing great. Like, don't doubt that you can be here and that you are wanted and valued and that your performance is just fine. And like, your grades actually don't define you or your ability to be a creative problem solver, which is the number one thing that engineers need to be. Like, not every engineer is going to be equally good at solving differential equations at high speed, which is sometimes what you have to do really well on your exams. Sometimes what you need is really good creative intuition about mechanical things and how they work, and just the willingness to try. You just have to find it from within yourself and go for it. There's been all kinds of things in my career that I totally wasn't prepared to do, but then I did them and I surprised myself. And then I was able to build on that toward future bigger things. And so that's what I'm always telling students who come to me with those kinds of concerns. Like, don't let it faze you. Just keep on doing your thing, right? Because you're more capable than you know. And you're very much wanted.
And how do they react?
Oh, usually, well, there's crying. I keep tissues in my office for that reason, but then they keep coming back, which means that they stayed, which is great.
That's almost it for today's show. I just want to share a couple numbers with you. According to the latest data from the American Society of Engineering Education, nationwide, female undergraduate students made up 23.8% of all students enrolled in the fall of 2019. Here at the Rawson College in the fall of 2020, women made up 32%. So like Hannah said, we are above the national average, 32% compared to 23.8%. And in case you're curious, Hannah Dailey is still the chief scientific officer of the startup that she co-founded. It's called OrthoXL, and it's based in Ireland. They design and manufacture nailing systems, basically long nails that fit inside the hollow spaces of your tibia or your femur, and they help fractures heal. Okay, that really is it for the show. Thank you so much, Hannah, for a great conversation. For more information about the academic programs at the PC Rawson College of Engineering and Applied Science, and to find our show, head to engineering.lehigh.edu. Music in this episode is by Blue Dot Sessions. You can subscribe to Rawson Connection wherever you get your shows, and send us story suggestions or feedback on Twitter @Rawson Podcast. Thanks for listening.